So the steps of the crystallization: number one, we will heat and concentrate the solution. When we use the term concentrate the solution, it means it contains less water and more salt. So heat and concentrate the solution. Number two, we will cool the solution. So filter to remove crystals from the solution. So example, we have a container and this container is having a solution. A salt solution is there. And this contains 10 grams of dissolved salt. So it contains 10 grams of dissolved salt, and the volume of this solution, say it is 10 ml. Now what we will do, we will heat this, we'll supply a heat energy and concentrate the solution. When I'm saying heat and concentrate the solution, means we are removing or reducing the amount of liquid. So example, now we change its amount to 8 ml. So now it is 8 ml. So originally it was 10, now it is 8. If 10 ml was dissolving 10 gram, so 8 ml contain or can dissolve 8 gram. So what happened to remaining 2 grams? So that remaining 2 gram will crystallize. So 2 grams will crystallize, or you will have 2 grams of crystals which will appear. But in a hot solution, the crystals will not appear because hot solution can still dissolve too much. So that's why we should always cool down the solution, and once the crystals form, we can filter it out. So the comparison in evaporation, actually we have to remove all of the water. So evaporation normally, because to remove all of the liquid it takes time. So evaporation is 100% accurate because you remove all of the liquid, but it takes time. In crystallization, it's not 100% accurate because still some of the salt is there inside the water. So it's not 100% accurate, but it is in a short time it can be done. Is it clear? The comparison between crystallization and evaporation. Is it clear? Any doubt?
Sir,
Yes.
sir, when we are using evaporation as the separating method, we
Hmm.
are not getting the solid in the form of crystals, right?
Then how we are getting a salt in the form of what?
Like we in both of the ways we get it in the form of crystals.
Yeah, both ways it will form crystals.
Then, sir, what's the main difference between them?
The main difference actually is the technique. In evaporation, you're removing all of the liquid. Like there is no liquid remain, so all the salt will be crystallized. When evaporation occur, all the salt is crystallized. But because why practically, like example, in a lab, we are not using evaporation, we use crystallization. Because to remove all of the liquid or to evaporate all of the liquid, we need greater amount of energy and we need more time. But in crystallization, we just evaporate small quantity of the liquid or remove small quantity of a liquid and make the solution concentrated. So it's less time consuming. So when we compare both, evaporation takes more time. You can find like example, obtaining a salt from the seawater. So what they're doing, because they're not heating by themselves, so they're making small ponds which where they keep this seawater, and due to the heat of the sun, as the water evaporate, at last all the evaporation occur and all the water evaporated and you're left with a salt which was dissolved in the water. So in crystallization, we don't remove all of the water. In evaporation, we remove all of the water. That's the main difference between them. In the lab, we normally prefer crystallization rather than evaporation. Number one, due to the consumption of energy, like it need more energy. Number two, it required more time to remove all of the liquid. Is it clear?
Yes, sir. Thank you.
Then a simple distillation. How we can use simple distillation? Simple distillation, it is used to separate liquid from the, if you want to separate liquid from the solution, like example, we need water from seawater. So we can use simple distillation. This is a figure which you have to memorize or learn the labels. So what happened here, you have a salt solution. You have a mixture or a salt solution. In simple distillation, it is a technique in which you obtain liquid from the solution. So you need water from salt solution. So what you will do, when you supply the heat energy, the water will convert into vapors. This water will rise. A thermometer will detect the temperature of the vapors, like it's equal to the boiling temperature or no. Then you have a condenser, or a Liebig condenser or a condenser. What is the purpose of the condenser? The condenser is used to remove the heat energy. So how the condenser remove the heat energy? This is a jacket of the condenser in which there is a cold water, a water which is cold. It is flowing here around it, not inside, around it. So this water which is flowing around it, it will take the energy from the water vapors, because what happened when you are heating, the water will convert into vapor. These red lines example representing water vapors. The water which enter will move in this jacket around it, and this water which is in the condenser will take or absorb the energy from the water vapor. When it will absorb the energy from the water vapor will turn into liquid, and then what you will have, you will collect a liquid at this point. So it is similar like evaporation, but in evaporation we don't collect the water. Here first we evaporate the water, convert water into vapors, and then we condense the water, converting it back from vapors to liquid state. Is it clear? So simple distillation, a process of boiling a liquid and then condensing the vapor to produce back the liquid. And it is used to purify liquid from separated mixtures. Any doubt in this? If you have any doubt, you can use your mic or chat to convey. Same thing. If we have two immiscible liquids, if we have two miscible liquids, liquids which mix with each other, so we can use fractional distillation. What is fractional distillation? Look, it is similar to that of separating funnel. It's similar to that of simple distillation. But in fractional distillation, what we have, one extra thing is there which is called a fractionating column. Example, you have a mixture. You have a mixture here of water and alcohol. Different alcohols have different, because there are different types of alcohols. So different alcohols have different boiling point. The boiling point of water is 100. Normally the alcohol which we use in the lab, it's having a boiling point of 78. But it's not all alcohols have, there are different types of alcohols. It's normally ethanol. Ethanol is a type of alcohol which is having a boiling point of 78. So what happened, when you supply the heat energy, both water and alcohol will convert into vapors, because evaporation or conversion of liquid to vapor can occur at any temperature. Example, the blue lines are representing alcohol and the red lines are representing water. So blue one is representing alcohol and the red one is representing water. What happened, as these water vapors and alcohol will rise in a fractionating column, because the boiling temperature of water is 100, whereas the boiling temperature of alcohol is 78. So water vapors required greater amount of energy as compared to that of alcohol. So when we supply the heat energy, first the vapors of the alcohol will rise and they will move through this fractionating column. When the vapors are moving through a fractionating column, they might lose energy and they will return back to the flask. So after losing the energy, they might return back to a flask. But we are continuously supplying energy. Again, they will get more energy, they rise more and then return back. We are continuously supplying energy until the temperature at this point is equal to or more than 78. If the temperature here at this point, example, it's 80 degree centigrade. So if the temperature is 80, what will happen? The alcohol vapor will remain in vapor form and they will move out. As they will move out, the condenser will remove the energy from them, and as the condenser remove energy, it will convert into liquid state. So we will collect an alcohol here. But what happened to water? The red lines are representing water. Because the temperature here is 80, so this temperature is less than the boiling point of the water. So even some of the water vapor will rise, but they will return back. They're not able to go out. Why? Because when they're moving through a fractionating column, the fractionating column consists of like fine beads or glass beads which collide with the water molecule and remove the energy from them. So water will return. Like if I make a fractionating column, this fractionating column consists of glass beads So what happened? As the water vapor rises, they collide with this. When they collide, they will return back because they lose energy. When they collide with a glass bead, they will lose energy and convert back into liquid state. But because the boiling point of alcohol is less than of water, so alcohol required less amount of energy. So even it collide, it will also return back. But once the temperature at this point is above the boiling point of one of the liquid, like example, the boiling point of one liquid is 78 and the other liquid which we are using, the boiling point is 100. So if the temperature at this point is about 80 or 82, so this first liquid will remain in vapor form and it will come out. When it will come out, a condenser will remove the energy and convert this back into liquid state. But the first liquid, which is having a boiling point of 100, is not able to reach the top. Why? Because before reaching that, it always convert into liquid state and return back. So fractional distillation is a process which is used to separate the miscible liquids, the liquids which can mix with each other that have different boiling points. So when the mixture is heated, the liquid with a low boiling point evaporate and turn into vapor and can be separated as a liquid. Those with a high boiling point will remain in a liquid state. Is it clear, this technique, fractional distillation?
Sir,
Yes.
how can I know that alcohol is completely now distilled?
Yeah, how you will know that the alcohol is completely removed? So when the temperature at this point, because what happened, the boiling point of alcohol is 78. So when the temperature at this point is 78, you can identify that alcohol, you're receiving alcohol. The temperature will remain constant for some time. But once all of the alcohol removed, then the temperature at this point will start to rise or increase. So when you're collecting, like example, if you have a mixture of alcohol and water, so because you're collecting alcohol, so temperature will remain constant at this 78 because the boiling temperature of a pure substance, it is fixed, so it will be around 78. Once the temperatures start to change, temperatures start to rise, like it becomes 79, 80, 81, and so on, it is rising. It shows that you are collecting now, all of the alcohol is removed and you will collect water now. So once the temperatures start to change, you will stop this process. Is it clear?
Yes.
And separating funnel, if you want to separate two or more immiscible liquids, liquids which does not mix with each other, we can use separating funnel. So this is name of a technique is also separating funnel. And so you have a tap at the bottom. So you mix two immiscible liquids, liquids which does not mix with each other. Example, oil is there and water. So oil and water, can you identify which will have higher density in this A or B, which is having higher density?
A.
A is having higher density because it's at the bottom, and B is having lower density because it is at the top. So example, you have water and oil. So what you will do, you will open the tap. When you open the tap, you will remove the water will be like you open the tap so that the water will come out from the separating funnel. You will collect the water. Once you will reach the oil at near the tap, you will stop. And this is how you separate two immiscible liquids. The liquid which does not mix with each other. Is it clear? A technique we use to separate. This is called a separating funnel. in which two liquids which does not mix with each other, you separate them. Then chromatography, we discussed this chromatography, but chromatography can also be used to separate dyes, colors, or amino acids. What are amino acids? Amino acids are colorless liquid. So if I want to, and there are 20 types of amino acids. So if I want to separate amino acids from each other, what I will do, I will draw origin. First I will use a chromatogram, then I will draw the line origin with pencil. Then I place amino acid here. But when I place amino acid, that part will become moist, but I cannot see because they are colorless. These amino acids does not have color. So these amino acids are colorless. Then we use a suitable solvent. And after using this solvent, what we'll observe that the chromatogram will soak up the moisture, the liquid will rise, but still we are not able to see any spot. Why we are not able to see any spot? Because these amino acids are colorless. So for colorless substances, what we will do, we will spray so for colorless liquids, we will spray with locating agent. What is a locating agent? It's a chemical which make these colorless substance visible or make them colored. So for colorless liquid, we'll spray chromatogram with locating agent. You don't have to learn the name of the locating agent. There are different types of locating agents. Resorcinol is there, one of them. But again, you don't have to learn or memorize the color. So for colorless liquid, we'll spray the chromatogram with the locating agent. As we spray with the locating agent, example, this is a spray of a locating agent. So as we spray, what we'll observe that the spots will appear on the chromatogram. Now the question is the sample of amino acid pure or impure? The sample of the amino impure because there are 3 spots. And then can you identify which amino acid is more soluble in the solvent? Green, yellow, or red?
Green.
Green is more soluble because it rises to a greater height. And the one which is more soluble, the one which rises more is more soluble in solvent. Or greater solvent. That's why it is moving with the solvent more. And how I can identify these amino acids or type of amino acids? So I can measure the RF value, and using that RF value, I can identify the type of amino acid. Is it clear? So how we can use the same technique, but only addition, if it's a colorless liquid, we will use a locating agent for amino acid. Take the screenshot. Now I'll discuss some questions related to the topic, so you will have a better understanding. Yeah, is it visible to everyone? Exercise separating mixture. I will discuss the question because MCQs, it's your understanding, so it's better you attempt by yourself. Uh, State the name of the process used to separate oxygen from liquid air. If you want to separate two or more gases, which technique we can use?
Fractional distillation.
So we can use fraction distillation or we can use diffusion as well. If you want to separate the individual dyes in the ink, which technique?
Chromatography.
Chromatography. If you want, leave this part, it's related to produce an ethanol from simple sugar. You will learn in organic chemistry, that's called fermentation. If you want to obtain water from aqueous sodium chloride, means if we need water from salt solution, which technique?
Crystallization.
Simple distillation.
Distillation or simple distillation?
Mr.
Yes.
How to separate gases by diffusion?
How to separate gases by diffusion? Basically, practically, actually, it's not done like this. Practically, fraction distillation is used, but how diffusion can also be used. So, you have a container, and this container is a porous container. Porous container means it is having small holes. And there is inlet for the gases to enter. And you have you have a mixture of oxygen and hydrogen. So oxygen, the total mass of oxygen 16 multiplied by 2, 32. The total mass of hydrogen 1 multiplied by 2, that's equal to 2. So which will diffuse faster?
Hydrogen.
Hydrogen. So when you enter both a mixture of hydrogen and oxygen inside this cylinder, hydrogen is much lighter. So through the pores, which gas will come out?
Hydrogen.
Hydrogen will come out. So which much higher rate or as compared to that of oxygen. So by this technique, hydrogen and oxygen are separated from each other. And when this gas will leave, we can collect this gas to another container. But this is practically diffusion is not used. Practically fractional distillation is used. So what we'll do, first we'll convert these gases into liquid and we use the technique of fractional distillation. The gas which is having a low boiling point will collect that first, because first we convert gas into liquid and then we use fractional distillation. So more appropriate is fractional distillation, but diffusion is acceptable. Practically diffusion is, yes?
Sir, won't the oxygen also come out of the pores?
Yeah, oxygen will come out, but the proportion is very small, negligible, because the rate of diffusion of hydrogen is much faster as compared to that of oxygen. So means hydrogen is moving from region of higher concentration to lower concentration at a greater rate. So yeah, definitely there are some molecules of oxygen will be released, but most of them are hydrogen. Clear?
Yes, sir.
If you want to separate precipitate means solid. Insoluble substance is also known as precipitate. So separate the precipitate when aqueous silver nitrate is added to aqueous sodium chloride. If you want to separate the solid from solution, what we will do? Which technique? If you want to separate the precipitate or solid from aqueous silver, so we can use filtration or we can use decanting. Both methods can be used. This was a planning experiment. I will just quickly go through and you will. So starting with a sample of amino acid, describe how to separate, detect and identify the monomer which make up the, means the particle, monomer means small molecules. So name the process used to separate the amino acid. Which process we will use if you want to separate amino acid? Which technique?
Chromatography.
Chromatography. Then the method used to detect the monomers after they have been separated. So what we will do, we will spray, we will explain the method that we will spray the chromatogram with the locating agent, which will make them visible. And how you will identify. So what you will do, you will measure the, like the first answer was chromatography. The second used to detect the monomers. How you detect the monomers? You will use locating agent. And the whole method you will explain, just the main idea I'm giving. And how you identify these, then you will measure the RF value. Is it clear? The monomer means the small molecules are known as a monomer. Describe how to separate the following. In each example, give a description of a procedure used and explain why this method works. Nitrogen from mixture of nitrogen and oxygen. Two gases you want to separate from each other. So which technique you can use?
Fractional distillation.
Fractional.
Fraction distillation. And why the fraction distillation will work? What is the reason why it will work? Because two gases will have different boiling points. Because fraction distillation work when two substances, two miscible things which have different boiling point. So describe how to separate. You will mention fraction distillation. Give a description of a procedure. What you will do, we will separate the two. First, we convert the gases into liquid state, and we separate the two gases on the basis of boiling point. Glycine from a mixture of two amino acid, glycine and alanine. Both are, and glycine has a lower RF value. Which technique you procedure, which method you will use? If you want to separate, chromatography will use, and then explain how it will work. That's your. Then magnesium sulfate from aqueous magnesium sulfate. Magnesium sulfate from aqueous magnesium sulfate means you need a salt from salt solution. How to obtain salt from salt solution? Which technique you will use?
Crystallization.
So you will mention crystallization, and then you will explain how you will do that or use that technique. Okay. If any question, anyone having a doubt, feel free to ask your doubts, because later you have to solve so that you don't find it difficult. The diagram shows an apparatus used to separate a mixture of water, a boiling point of 100, and ethanol of a boiling point 78. Complete the boxes to name the apparatus. What we call this thing? What is this thing?
Fractionating.
No, the first one. I highlighted this. This one, what we call? Any idea?
Stand.
Stand or tripod stand, you can say. Actually, it's a tripod stand, but one of the leg cannot be seen because of the figure dimension. It's actually a tripod. Means stand with the three legs is called a tri. Tri means three, and pod means legs. So it's tripod. You can say tripod stand or stand alone. You can also say, that's correct. Then what is this? This part is called fractionating column. Then label arrows on the condenser. So for a condenser, always the cold water will enter and the hot water will go out. Why the water will become hot? Because this water, when it is moving, it will absorb the energy from the vapor and then it will leave. Identify one mistake in the apparatus. Can you identify a mistake in this? Any mistake you see in this apparatus? Identify one mistake in the apparatus.
We are also providing heat on the
Yeah,
collecting beaker.
so collecting beaker, yeah, that's a mistake that we should not do. Good. Which liquid would collect first? Which liquid will collect first, and explain your answer. What will collect first? Ethanol or water?
Ethanol.
And what is the reason for that?
It has lower boiling
Lower
point.
boiling point, so it will vaporize first. Why would it to be better use electrical heater instead of Bunsen burner to heat water and ethanol mixture? Like here we are using a Bunsen burner. Why electrical heater is suitable or better as compared to Bunsen burner? Any idea?
We can
Like,
know the heat supplied.
yeah, but there is also one safety precaution. Basically, what happened? Ethanol is a flammable liquid. Alcohol can catch fire. So actually, if you are using a burner, it is exposed to the flame. But if you use electrical heater, because normally what happens in electrical heater or a water bath, water become warm because of the heater, and that warm water will supply the energy. So ethanol is a flammable liquid. It may catch fire. We can control temperature. That's also a reason, but the main reason, which is related to a safety precaution, is ethanol is a flammable liquid, so it may catch fire with the flame. So when we are using an electrical heater, there's no flame in electrical heater, so it reduces the chance of that ethanol may catch fire. Nickel sulfate is a blue crystals. Plan an experiment to obtain pure water from this salt, and use your answer should include the diagram of the apparatus, any expected observation, and test to show the presence of a pure water. First thing, what method we will use if we want water from this salt? Which technique?
Simple distillation.
Simple distillation. So basically what we will do, we'll use simple distillation. So here we will have the crystals of or hydrated crystals of sodium sulfate, nickel sulfate, and we will supply the heat energy, so they release the water. That water will condense and it will be liquefied at this point. A sample of furniture cleaner contained aqueous sodium chloride, aqueous ammonia, and sand. Plan and investigate to obtain a sample of pure water from the mixture. You have dissolved sodium chloride, you have dissolved ammonia, and you have salt. You want to obtain pure water from this mixture. How you can obtain a water from this mixture? Which technique?
Fractional distillation.
Yeah, or simple distillation. Because fractional distillation, if liquids are mixed with each other. But here you have a solutions. Like aqueous sodium chloride is a salt solution, aqueous ammonia and sand. So we will use simple distillation. And then plan and invest how you will do that, because it's of 2 marks, so you have to explain that how you will carry out. If you want pure sand from the mixture, what you will do? Which technique?
Filtration.
Filtration, and then you will